Wet bulb temperature is one of those features of climate change caused by global warming that often gets left out when discussing the radical changes our planet is going to experience in the coming years. Discussion has largely focused on issues such as drought, hurricanes, tornadoes, storm activity, and even unusual cold. The impacts of increased heat have been left out because we assume, incorrectly it turns out, that human beings can adapt to moderate increases in global temperature. This turns out to be false, particularly in areas prone to hot and humid weather. It all comes down to one measure: wet bulb temperature. Wet bulb temperature is the one factor, more than any other, that can render entire regions uninhabitable. Wet bulb temperature is essentially the temperature of a wet thermometer bulb such that the water is able to evaporate into the air. As the water on the thermometer bulb evaporates, it carries heat away from the thermometer. Therefore, unlike with a dry bulb thermometer, which measures ambient heat, a wet bulb thermometer measures the temperature of air if it were cooled such that its humidity reached 100%, at which point evaporation stops. You can measure it using a device called a sling psychrometer. The psychrometer contains two thermometers, one for the dry temperature reading and one covered with what is called a sock for the wet bulb reading. The sock is the reddish-white thing on the end of the upper thermometer on the left of the picture. At 100% humidity, the dry and wet bulb temperatures will be the same. Otherwise, the wet bulb temperature will always be lower than the dry bulb. This means that, while dry places do tend to get very hot, they are also very good places to use evaporative cooling. Humid regions, on the other hand, can only get so hot before evaporative cooling breaks down. The reason it is important is because human beings and other warm-blooded animals rely on being able to release heat into the air through sweating, panting, or other means, releasing water in the process. A human being's body maintains 98.6 degrees Fahrenheit, 37 C, by transporting heat to the surface of the skin where it is evaporated off with sweat. But sweat can't evaporate if it isn't dry enough, as anyone who has been out on a muggy day knows. Heat stroke is a major cause of death, with the recent heat wave in the Pacific Northwest causing 60 in just a few days. Once the human body reaches 108 degrees Fahrenheit, 42 C, the body dies, and vulnerable people can die much sooner and at lower temperatures. About 700 people per year die of heat stroke in the United States alone, a place with ubiquitous air conditioning. Recent studies find that outside the US, the death rate is much higher at 300,000 heat-related deaths annually worldwide, with about 1/3 of those related to climate change. Without refuge in cooled buildings or spaces, human beings cannot survive where it gets too hot and humid, especially when it does not cool sufficiently at night. While triple-digit dry bulb temperatures are frightening, until it gets up into the 120s F, 49 C, people in dry regions can seek shelter and, because of the air's near-infinite capacity to absorb water, survive. Humid regions, however, can have wet bulb temperatures in the mid-80s F, 26 to 32 C, with only moderately higher dry bulb temperatures, which is sufficient to kill vulnerable people such as the elderly. For example, heat waves in Europe in 2003 and Russia in 2010 killed thousands with wet bulb temperature about 82 F, 27 C. Wet bulb temperatures that are too close to the body's own internal temperature can cause death within a few hours by overheating. This happens even if the person is in the shade, without clothes, and using a fan. Unless they have a compressor-based air conditioner to cool and dry the ambient air, they will die. When heat from sunlight is included, the problem is even worse. A wet bulb temperature of 95 degrees Fahrenheit, 35 C, is incompatible with human life. While a wet bulb temperature that high has almost never been observed anywhere in the world, high wet bulb temperatures have become more common in the last 40 years because of global warming, striking diverse places from India to the Middle East to Australia. Mostly these have been in sparsely inhabited areas, but if a high wet bulb temperature were to strike a heavily populated area and last for more than a few days, it would be as devastating as a major earthquake or epidemic, with 1,000s dying per day. Unlike earthquakes or epidemics, however, a region that experiences annual long-term high wet bulb temperatures would be essentially uninhabitable, since the local population would not be able to survive without some kind of air conditioning or hiding underground. Several weeks of high wet bulb temperatures would be sufficient to kill most of the people and animals in a given region. What this means is that those regions will become empty of people, and those people will need to go somewhere cooler. In some cases, this could create a significant refugee crisis. More worrying still is that increases in wet bulb temperature, heat, and duration are already happening decades earlier than they were predicted to happen. This means that whatever mitigation strategies we hope to roll out for stopping climate change are already too little, too late. This world will need to adapt by relocating entire populations. Whole cities in places like China, Southeast Asia, and South Asia may become empty if they cannot put in sufficient cooling infrastructure. And if you don't think it will happen where you live, that depends. The worst affected regions may not be the most southerly. They will be the most humid ones. Coastal regions are particularly vulnerable to long periods of humid weather, as this map shows. This means more investment in reducing emissions, but also in mitigating what is already happening. Building walls to hold back the sea that is rising is important, but equally important is being able to survive long periods of hot weather. Stopping the production of excess carbon dioxide will not cool the world overnight, even if we went 100% carbon neutral. The oceans would continue for decades to bring heat up from the deep where it has been stored up. It will at least slow the trend, however, and that is important, potentially saving entire nations from devastating heat and millions of lives.